Noise immunity is a useful attribute in digital HF communication, so I can understand why it was done like this, but it also means that either signal was sufficient to start to decode the information. We can use Universal Radio Hacker to show us only half the signal using a band pass filter. I then decided that the 40 kHz frequency was on and represented by a 1, and the 7 kHz frequency was off, represented by a 0. Of course, that's entirely arbitrary. There's no reason that it cannot be the other way around, but for our purposes it doesn't matter at this time. That said, we don't yet have enough to decode the actual signal. We need to figure out how long each switch, or bit, lasts, because 2 zeros side by side or 2 ones side by side would look like a long off or a long on. Using that logic, you could also say that the shortest possible duration for a 40 kHz or a 7 kHz tone would represent a single 1 or a single 0. Of course, this is a simplified view of the world. For example, the data file contains more than 13.5 million bytes. Half of those are for the I in IQ, the other for the Q. I'm purposefully glossing over a bunch of stuff here, specifically the notion of so-called IQ signals. That's for another time. In computing, a single byte can represent 256 different values. It means that if the signal is represented by a single byte, a voltage from the antenna at maximum amplitude can be represented as 255, and the minimum amplitude as 0. As it happens, voltages go up and down around 0, so now we're only using half a byte, 127 for maximum, minus 128 for minimum. If we use 2 bytes, we get significantly more resolution. Minus 32,768 as the minimum, and 32,767 as the max. A little trial and error using another tool, in Spectrum, told me that the data was organized as 2 bytes per sample, which brings the next point. How many samples per signal? Said differently, we're measuring the antenna voltage several times per second, let's say twice per second. If a tone of 7 kHz lasts a second, then we get 2 samples showing 7 kHz. If it lasts half a second, we only get 1.